Hello, welcome to this video. Today I'll show you how to segment and analyze a phenomenon called EHO. Here it's called endochondral heterotopic ossification, and it's a kind of pathologic bone growth in the mouse leg. You can see here a CT scan of a mouse. It's cropped already, and it's part of our tutorials here. You can find it here. Endochondral heterotopic ossification, and load it, and then you can see also the segmentation here. And this is the bone growth region. In the CT you can see it as bright regions, maybe not as bright as the cortical bone, but it tends to get brighter over time. So the intensity is not a safe way to distinguish it from the cortical bone. And it tends to attach also to the bone, even though it doesn't originate from there. It kind of starts in the muscle, and then when it finds the bone, it connects to it, and you can see it in 3D here. But it's it's connected here. Not necessarily. This is like free, not connected, but this part is here. Now the challenge is to segment it, to separate it from here the tibia and the fibula, and then determine the statistics, like the volume here, or the mean intensity, or the overall amount of calcification in it. So I'll show you how to do that, and let's just delete the classes first and start from scratch here. And the first step would be to find a threshold using the windowing. You can use ISO rendering to find a threshold because you see everything above the center value, and we move the slider until we find a good threshold. So maybe something like 600, and let's add a class temp and do a thresholding everything above 600. Now we have a green class temp here, where we have these all the dense parts in it. Now we can add a class EHO, and for example this guy we can pick using the fill region tool, separated, but this doesn't work here on this, so we get the whole thing. So what can we do? We can use here the 3D drawing tool and just select the temp as input class, EHO as output class, and then draw in 3D. So it'll take whatever we cover here with this drawing. We can do this a few times from a few angles here, and fetch the region. Now we got something wrong here, so we can do this the other way around. And we can also hide the EHO class here to see where we have something missing. Maybe this one here. If you did something wrong, you can undo and try again. Let's show it again here. So now we have the EHO separated. Maybe this one we can improve. And Now let's fetch also the tibia in a similar way, but I'm changing the class color of tibia to be more different than the temp class. So this bone here is the tibia. And this one is the fibula. And this guy also belongs to the fibula, so we can grab it like this. You can also measure lengths, by the way, here in 3D. So the length of the tibia, like this, can be measured. Or the fibula. Yeah, now we can evaluate the statistics here, and we get the volume of the regions here and their mean intensity in Hounsfield unit, because that's the voxel unit that was loaded with a CT. So you see that the EHO is less bright than the other bone regions here. And you can see that in the CT here also. It's less bright. But yeah, that might be helpful, but I'm not sure if that is really a reliable method to separate it. Okay, I hope this helps. Thank you. Bye bye.